Hi class. I noticed that a lot of us are having a difficult time with this week's discussion. I wanted to do an actual example in real time. Now, all I'm asking you to do is to prove, to show, to demonstrate that a linear graph, which would be a graph like what you see here, a straight line, has a constant rate of change, which means that the slope is always the same, regardless of what 2 points you pick to calculate the slope, as compared to a nonlinear equation, which would be like this one, right? It's not a straight line. A nonlinear equation would be an equation whose graph is not a straight line, like this parabola that you see on your screen. So what I'm asking is for you to pick 4 points on this parabola, 4 points, 4 different points, and then pick 4 different points on this graph. Now, I know there are a whole bunch of graphs on here because I couldn't get rid of them, but I'm talking about this graph right here. Pick 4 points on this graph and then use those 4 points to demonstrate or to show what I'm talking about, which is the slope should remain constant, should remain the same for the straight line, regardless of which 2 points you're using. And the slope here should vary when you pick two different sets of points. So I'm going to do this calculation of the slope using a slope calculator. Why? Because I don't have anything to write with, and when I write, you can't see it, right? So the quickest way for me to do this is for me to use a slope calculator, and you feel free to use it too if you want to use it. All right, it's online. You can see the URL is calculator.net/slope dash calculator.html. So I'm going to pick my 4 points to prove my point. Okay. Let's say for the straight line, I pick the following points. I pick the points -1, 1, because this is -1, 1, and the point 0, 3. This is the point 0, 3. -1, 1, 0, 3. So those are my 2 points. -1, 1, 0, 3. And when you do it by hand, you're supposed to do y2 minus y1 over x2 minus x1. This does that for you. Oops. -1 is supposed to be -1. So -1, 1, let me double check. -1, 1, and 0, 3. Okay, so let's plug them in. -1, 1, and 0, 3. This is the first point, and this is the second point. Okay, calculate. The slope is 2. It calculates a whole bunch of other things here, but that's not what we're looking for. We're just interested in this, the slope. It's 2. Okay, now I'm gonna pick another two sets of points. So let's say I go with the point 1, 5 and 3, 9. 1, 5, 3, 9. Let me calculate that. 1, 5, 3, 9. I still get 2. So that tells me the slope is constant. The rate of change is constant. Now I'm going to show that the rate of change for a non-linear, a non-straight line is not constant. So I'm gonna pick 2 points, any 2 points. My first point, I'm gonna choose 0, 0. See, this is the point 0, 0. This is the point 0, 0 and 1, 1. My first point, I'm gonna use 0, 0 and 1, 1. 0, 0, 1, 1. The slope is 1. 0, 0, 1, 1. I found the slope, it's 1. Now, I'm gonna pick 2 new points. This time I'm gonna do 2, 4 and 3, 9. 2, 4 and 3, 9. Keep in mind we got 1 when we did the first slope for the quadratic. So 2, 4 and 3, 9. 2, 4, 3, 9. Let me just double check I have the right points. 4, 3, 9. Okay. So calculate. And we get 5. See, for the non-linear graph, we got 2 different slopes, 1 and 5. But for the linear graph, we got 2 and 2. That's all I'm trying to say here, that the slope is constant when the line is straight, when it's linear. And the slope is not constant when the line is not straight. That's all you have to do, ladies and gentlemen. That's it.